Hello everyone, this is Satish here, and along with me Avantika and Mahesh Raju also here. So here I'll be presenting and also demoing the feature which we developed as part of GoldenEye release, that is PCE and PCCC as a SDN transition solution. So here first I'll just give an introduction what is PCE before going for the demo part, and also I'll just give a glimpse of what is PCCC as an SDN transition solution. Then we'll go to the demo part. So we know like what is PCE is a path computation element. Basically it computes the path between the two endpoints in the network, whether it's MPLS network or any type of IP network or anything. So it takes few constraints as an input, so it computes the path with this with satisfying these constraints. So this is the path computation element. So this can be the network or it can be in a centralized place like SDN controller. So next we will see what is PCCC, and PCCC is a PCCC as a central controller. So the difference between the PCE and PCCC is like in PCE only the computation part is being moved from the network to the controller. So but still the control plane is with the network only. And in case of PCCC, the complete control plane also has been moved to the controller, and only the basic data forwarding is being handled at the network side. So as part of PCCC, we know like the problem which you are trying to solve is like we know the complexity involved in the development and maintaining this IP and MPLS technologies. By moving to this to the central entity, it's very easy for managing the network also and maintaining it as well. And also in order to in the earlier network, if you see, it's very difficult to add any new services or any applications which is service oriented. So now since it's in the controller, we can write many apps like which can control your network using PCE, which we are developing. And also earlier it was distributed. We know like when it is distributed, the complexity involved in distribution as well, there was no synchronization for the LSPs when it was distributed. So if you see earlier, it was using CSPF, where only the ingress node has the knowledge about the particular path. So other nodes doesn't know like what is the path being computed by the other devices in the network. So by this we are losing the optimization mechanism. So we cannot optimize your paths. Also it goes by a order based, the way in which the order in which you configure it goes like that. So it gives a lot of other complexities in order to tear down and build the new path. Also this network use cases, if you see PCCC, it can be satisfied for data center, core, SDN and transport network. And if you see the key text for the PCCC, like segment routing also is being used by PCCC, and path and IP plus optical. So also together can be by both IP plus optical network together we can compute the end-to-end path. And we also have an hierarchical PC where we have layers of controllers, so which talks to each other when the network goes very big. And as a network resilience, we have is very good for it, like when any network changes happens, it can detect it and it can recompute it. And also it's more of application aware, and it's a smart TE where applications can be more intelligent enough to monitor it and optimize your network. So in this project we have developed two cases, PCE as well as PCCC. So as I discussed, PCE earlier we are having CSPF where it's been completely distributed, and LSP path taken completely depends on the order of configuration. So now as part of PCE we move to the central entity where it has the complete global picture of all the paths, and it can optimize it completely for the network. As a part of transition, if we see like even with PCE, we have the signaling mechanism in the network only. We use RSVPT signaling. So towards PCCC, complete signaling is removed, complete control plane is removed. So here all the devices connect to the owner controller, similar to the OpenFlow. So controller has the logic to push the labels and the flow rules to the network based on your requirement. So by this way, its complete control plane is removed from your network and complete logic is with your controller. as part of PCE, we support 3 modes, that is basic PCCC, SRB is best effort, and SRT is segment routing traffic engineering. So in basic case, we remove complete RSVPT case, but here the labels are local to the LSPs, it's not global. with respect to SR cases, it is segment routing mechanism we are implementing by using PSUP protocol. So this is about PCE and PCCC. Now we'll go to the demo part. So we'll see how we have developed it and how we can configure it, and we'll show how we set up or delete the path. This is our demo topology. Here we have 8 routers, and it is single AS and single domain, and all are connected in a mesh network. So we have single node in our demo, not in cluster mode. So this is connected to this devices for PCCC case, or in case of normal PC, only to the ingress connection is sufficient enough. So as part of this demo, we'll cover both PCE and PCCC. For PCE case, we'll cover setup the path, query path, and update path. For example, we'll choose like bandwidth change as one of the constraints, where changing the bandwidth for the existing path which you already set up. And as part of resiliency, we'll see like making the link down, and we'll see how the network reacts, how the controller reacts, and recompose it and make your path, recompute the path and set up the network again. And we'll see the delete case as well. So similarly for PCCC, we'll see one mode, that is SRT mode. So SRT mode also we'll see like how setup, update, and delete path is there. As part of the G-release, we also supporting the other 2 modes as well, basic and SRB. So since we don't have much time now for the demo, I'm just skipping this part now. So this is for the demo cases. Then we will show like in the real time how in the demo with the network connections and the owners, we'll show how this being achieved.